Welcome to Talk Universe. I'm your host, Sir Charles Schultz, and I'm coming to you from our virtual Mars gallery in our Universe Science Center, the virtual gallery of all the things that you might want to explore and walk around in. I do not generally editorialize, but I've come across an article that I think is going to catch a lot of interest. And in the article, it was claimed that perhaps when we went to study Mars, we had accidentally killed the life on Mars. Now, after reading the actual article, I understand that the author didn't truly, I don't think that's what he really meant to say. And the paper that it's based on is very clear that the scientist who wrote the article felt that by using water-based food to test bacterial action in the soil, we had somehow killed it. And I can kind of understand his thinking about it, but it really doesn't make a lot of sense. So let's have a look at the article itself. As you see, it says, whoops, NASA might have killed life on Mars. And it shows this beautiful picture of the red planet. Now, one of the things that stands out is that the researcher made an honest effort to understand that let's say the adaptation of the bacteria that might live there might bring it to extracting water from salts. And that by using water-based foods, we would somehow, let's say, overload it and kill it. That liquid water would be more than enough to actually wipe out that life. So it didn't really, as the article implied, destroy all life on Mars, but it would really have been limited only to the sample containers themselves. Now, for those who are not familiar with the history, we sent two early landers to Mars called Viking 1 and Viking 2. And in those days, in 1976, when the landers struck the planet, they really had no idea what they were going to find. Now, they had an experiment called the labeled release experiment. And the labeled release experiment was one of these things that would depend on metabolic action. And it was designed by Dr. Gilbert Levin. And he used food in solution tagged with radiocarbon, carbon-14. And in the process of metabolizing the food, the carbon-14 would end up as carbon dioxide being exhaled into the sample container, and then you could measure the radioactivity and know if there had been metabolic activity. So they did this experiment 2 times on each lander. In the first sample, a bit of soil was introduced into the chamber, and the soil reacted. And it reacted in a way that indicated some sort of bacterial action. And it went on for a couple of days, and they could see that the gas evolved followed the circadian rhythm of Mars, a little bit over 24 hours, 39 minutes and change. When they put the second sample in, they baked it to sterilize it. And this was their control. If we put in sterilized materials, will it react the same way? And in baking it and putting the new sample into the second test chamber, they got no results. Nothing happened. So it was a pretty good indicator that heat had killed whatever might have been in the soil. This was done on both Viking 1 and Viking 2, and they landed in 2 different areas of the planet. One landed in Chryse Planitia, one landed in Utopia Planitia. Now remember, this was 1976, so nearly 50 years ago. I must admit that I was not impressed with the way NASA responded to it. They dismissed it by saying, oh, well, we tested it with another instrument and we didn't find any evidence of organic matter. Now understand, the instrument they used was called the GCMS, the gas chromatograph mass spectrometer, fancy name for saying it had the ability to detect organic compounds and generate a kind of graph showing what those compounds might be by their molecular weight. Unfortunately, the GCMS is blind. They spent about $55 million designing and flying those instruments, and the problem was they didn't work. And it was noted in an internal memo that it would be unfortunate if the taxpayers discovered they'd spent that much money on an instrument that didn't work. And in the dollars of that day, that would be a huge amount today. So they flew it anyway, even though they knew that it didn't work. And testing later showed that for the GCMS to work, it literally would have to have a sample of about 1 billion cells in order to detect organic molecules. So it was a bum instrument, and they used it to discount the findings. Now, what stands in my mind, which is very, very different from what you might expect to hear from NASA, and I'm going to get some pictures here to show you. Past the cover on the article, We know that there are marine fossils on Mars, and this is another thing that NASA has not embraced. And I'll tell you why the water theory does not work. It would not have killed the organisms. We see right here a cracked open nodule with mud, and in it is absolutely clearly a sea urchin fossil. And I've colorized it here so you can pick it out. And if you'll compare it to the image on the right, you see this is indeed the mouth of an urchin. It has the radial and circular patterns that you'd expect on any sea urchin. Also, it's very clear that there's mud and water on the surface of the planet. We can see a trough with mud right here from Opportunity on Sol 81. Now, you're wondering about the colors of these pictures, and I'll show you. These are, in fact, true color images. I did the processing myself, and my experience in optics and working in a dark room doing color separations, all of these things gave me the experience and the hands-on approach to let me understand how the color works. And so you can see very clearly, there's Old Glory, red, white, and blue, and the colors are correct. You can see aluminum and stainless have a different look. The sky reflected in it is not orange murk. The insulation is Kapton, the colors are correct. So this is a true rendering of what the color on Mars would look like, even to the human eye. We can look also at another sample I found much later in Curiosity's data. These are barnacles on Earth. These are barnacles on Mars. And let's just zoom in. You literally can see the shape of the mouth, the shape of the barnacle itself, and there's a whole cluster of them on this rock. The rock is literally covered with barnacles. And in some, you can actually see the teeth in the mouth, the operculum plates. So this is not an illusion. These are actual marine fossils on Mars. And if you look a little closer, Curiosity also, Sol 3321, we can see spiny urchin fossils. We can see other urchin fossils. You can see the patterns match urchins on Earth. You can see the rows of bumps, you can see the segments of the shell, and in this case you can actually see the spines. So, if we look at this assortment, you've got coral, you have seashells, you have urchins, you have trilobites, you have sand dollars, you have all sorts of obviously organic remains. So getting back to the article, what in the world are they talking about? Well, it's very simple. If we have all this water on the planet in the form of frost and fog, dew, all of the things that we see, and we also see water ejection in certain areas, flow on the ground, we know that liquid water would have been present all along, even in the form of ice and snow and other forms. So the theory that the presence of water would have killed the organisms is not correct. But at this point, they're actually saying it might have been organisms. This is a huge step for NASA because they have absolutely denied all this time that this would be organic life. For some reason, to them, that seems to be the most horrible conclusion you could draw. Now, when asked why they would do that, I would have to simply say that, there's a lot of money in exploration. And over the last 20 years, NASA has, by my count, found access to like $350 billion. That's an awful lot of money. And maybe I'm wrong, but just looking at their yearly budget, they've got well over $350 billion in hand over the years. Now, it's really a shame because we see honest intellectuals trying to write an article about something and saying, well, maybe there was life, but it's so sensitive to the presence of water that it would never be a threat to us because we got some water on the planet and it killed it. Really, that's not a feasible or believable hypothesis. But what I would like to point out is, knowing that you see marine fossils, knowing that there was an active biosphere of some complexity, we also know very clearly that any sample brought back to Earth might contain organisms to which we would have absolutely no resistance. Now, I really would like to say there is a struggle over the last, there's been a struggle for 20 years now, to bring samples back from Mars for analysis. And they always say, well, we want to get them to the laboratory, analyze them, and see if we can find life. I think this is a very, very foolish idea. We recently have had incidents where biological materials have escaped from laboratories, research facilities, and ended up in the environment. We literally, as humans, do not have the technology to safely contain a sample from Mars. And so the best solution is, for now, let it alone. But what I would say is, we're now planning Mars missions, and Elon Musk is planning on getting there in a very short period of time. We will probably see hardware on Mars that could support human life, habitable modules, that sort of thing, within the next couple of years. We certainly are going to see some landings from SpaceX. And so we really need to know, if we send somebody to Mars, could they ever return to Earth? I don't think so. We're running a real risk by bringing back samples from a known alien biosphere. So, in my estimation, it's the worst possible thing we could do. I think we need to take this into consideration and put a stop to it now. At the very minimum, get some sort of safety protocol in place, something that'll prevent it from happening. It shouldn't come any closer than perhaps a laboratory on Earth's moon. In the meantime, let's keep looking at the data, and let's get NASA to admit what they found. It's very, very obvious. I want to pitch my book, A Fossil Hunter's Guide to Mars. I just finished the second edition. It has all of the last 20 years of research loaded in it, 540 pages or so, and I think that you'll really enjoy it. And I urge you, go to the Schultz Laboratories website, order the book. You can get it as a flash drive, mailed directly to you, or you can get it as a digital download. So I really hope that you'll take an interest in it. Have a look. Support us in our effort to stop the Mars sample return, because it is something that could pose a grave threat to life and biology on Earth. And thank you for watching today. I'm Charles Schultz. This is Talk Universe. Have a wonderful life. Thank you.